this section we're going to teach you the partial fraction decomposition process. You know already how to add fractions together or rational expressions together to get a combined form. Now we're going to be splitting them up. Notice how I've already got this first denominator factored into two forms, into the two parentheses. You know that your two denominators are probably going to be x minus 5 and 3x plus 1 when we split this fraction apart. Notice we've got our denominators. We now need to find out what the numerators are, and they're going to be a and b, and we will find out what those are later when we teach you the main process. Right now we're just working on the setups. In this second problem, we notice that the denominator is cubic. We can begin by factoring out an x, have x squared plus 4x plus 4 left over, and that is going to factor into x times x plus 2 quantity squared. So you would think that when we split this up into partial fractions, that our two fractions are going to end up being something over x plus something over x plus 2. Well, it turns out we need a third fraction with x plus 2 quantity squared. The common mistake people make is that they don't put this middle one in there. They just say, oh, I need the first one and the last one based on how it's factored. But since x plus 2 is a subset of x plus 2 squared, it's possible that there is a fraction with this as the denominator as a building block. So our numerators, we will find a, b, and c later when we play with this. Okay, for the next one, we can factor a 7x out of the denominator and have x squared plus 6. Okay, you can probably guess that we will have denominators of 7x over here at the right and x squared plus 6, and you would be correct. But the numerators are going to turn out to be different this time. We're going to have a over the 7x, but we're going to have bx plus c over the x squared plus 6. You see, since this is a quadratic denominator, we want a linear numerator. We want the degree of the numerator to be 1 less than the degree of the denominator. Well, you may look at that and say, well, what about the problem that we just did a moment ago where we had x plus 2 squared? Isn't that quadratic? Well, yes it is, but it was formed by a linear term squared. When it's a linear term squared, we only need the single variable up in the numerator. But when it's a quadratic term naturally that doesn't break down, then we need the linear term bx plus c up there in that numerator. So there's a slight difference between the two procedures. In this next problem, it factors into x squared plus 3 times itself again. So in the partial fraction decomposition, we will have one fraction with x squared plus 3 alone, and another fraction with x squared plus 3 quantity squared. And we will end up having ax plus b in the first numerator and cx plus d in the second numerator.